Our learning goal today is that you can add and subtract polynomials. But what you need to make sure that you're, and especially in these notes today, you have to show, why is it possible that we can do the things that we can do to add and subtract them? You're going to feel like you're simplifying, because in reality, that's kind of the same thing as what you are doing. So what we're going to do is we're going to identify like terms, which we already know how to do. We're going to rearrange, putting the like terms together. In other words, we're going to say, you guys can be added together, so let's put you here, followed by this group of like terms, and so on until we have them rearranged to put them together, and then we will combine like terms. We're first going to practice just adding and subtracting monomials. There'll be no parentheses involved because we're just going to be adding monomial terms together. So in number 1, do we have any like terms? Okay, which monomial terms are like each other? Noah?
2x squared and 3x squared.
2x squared and 3x squared. Well, they're already beside each other, so do we need to rearrange? No. If we were gonna, and it's always nice if we have only one variable involved to also have our answer end up in standard form. The more you can just keep practicing putting something in standard form, the better it's going to be for you. So if we combine the 2x squared and the 3x squared, we can say these guys can be put together, and what do they become? What is 2x squared plus 3x squared? 5x squared or 5x to the 4th?
5x squared.
5x squared. When we're adding, they stay what they are. So x squareds added to more x squareds stay x squared. So we have 5x squared. Does that x have anything to be added to? No, there are no other x terms. And can 5x squared and x now be combined?
Yes.
Are they like terms?
No.
Are x squares the same as x's?
No.
No, they're not. I mean, it's kind of like saying that an orange is like a tangerine. Even though they're the same color, it does not mean they're the same fruit.
And they're both citrus fruits.
Yeah, and so x's, they look, x's are x's, they look alike, but one of them is being squared, the other one is not, so we can't combine them, so we would say this is our sum, because all we were doing in this one was adding. So our polynomial sum, it just became a what? Now tell me what kind of a polynomial that is.
No, it's quadratic.
Riley?
What do you say?
Oh, you raised your hand. Thank you for raising your hand. A quadratic binomial. It's degree 2, so it's quadratic. It's a binomial because there are 2 terms. Is it in standard form? Okay, so what's its leading coefficient?
4.
Noah?
5.
5. Okay. So all these things that you just keep processing through and making sure that you understand them. Okay, number 2. Do we have any like terms? Noah?
Yeah. 4z to the 4th and 16z to the 4th.
Okay. And then do we have any other sets of like terms? We have some, what are those called that?
Constant.
Constants. We have some constants involved there. You know what I want us to do first of all, because this is going to be helpful. Right now you're going to feel like it's a waste of your time. But trust me, when we start multiplying, and in advanced algebra, when you start dividing polynomials, it's going to be helpful to make sure that you are treating the addition and subtraction properly. So let's first of all change our subtraction to add the opposite. So we're going to make this 4z squared. Instead of subtract 8, we're going to change it to addition. And the opposite of 8 is?
Positive 8.
The opposite of positive 8?
Negative 8.
We changed the subtraction to positive, to addition I mean, and 8 is what was being subtracted. The opposite of it is negative 8. Because in reality, the subtraction can't be rearranged, but addition can. So we're going to change it to addition first so that we can rearrange it. With this one already is addition, so we don't need to. And that one's already addition, so we don't need to. Now I want, in your notes, I want us, especially in our notes, to show that we are rearranging it now. So let's put that little note over here, rearrange. That's what we're going to do in this next step. Maybe for some of us, a good thing to write here too is because that's, maybe you'll be confused, what were we doing in that step? We were add the opposite. Okay, so if we wanted this to end up in standard form, which group of like terms should come first?
4Z.
The z's to the fourth, right? Yeah, the z's. We only have one group of z's in this, and they are z to the fourth. So we will rearrange it so those two are going to get added together at the beginning, and then followed by the constants being added together. So we're just kind of rearranging it so that our groups of like terms are beside each other. So what do we have now? What can we do? Riley?
20z to the 4th.
Okay, these can be added together, and we're going to get 20z to the fourth.
-6.
And then we have our -8 that can be added to 2. That becomes -6. And then we can just clean it up, right? Would we see it this way in an answer bank? How would it show up in an answer bank?
Probably 20z to the 4th minus 6.
Okay, 20z to the 4th, subtract 6. Cleaned up, this is how it would be shown. And because we already talked about if we start with the z to the 4th, would it be in standard form? Our answer's in standard form. Riley?
What's the point of doing that the opposite?
I just kind of want us to get in the habit of doing that, so when we start having to multiply and add, we're going to have the right things, the right terms that we're working with. Okay? So I just kind of want to get to, because I don't think your other teachers
It's always
were.
going to be a negative.
It's always going to be.
Add the if it's add the plus and the minus.
No, not necessarily. If you're subtracting a negative, is it going to be add a negative? It's going to be add a positive. So it's especially when you're multiplying, and then you're going to have adding to do with them, you will end up being more successful if we just kind of get in this habit right now. Okay? Is it in standard form? What kind of a polynomial answer do we have? What kind of a polynomial? Just classify it for me. It's not a quadratic. Noah? Riley?
Quartic
A quartic, because it's degree 4, so it's quartic, and it's 2 terms, so it's binomial. Quartic, binomial. Okay. Number 3. What's the first thing we're going to do? Look to see if there's any subtraction and change it to add the opposite. And we have a couple of subtractions. So we have 2x to the 3rd power plus 7y to the 3rd power plus, if we're changing that to subtraction, or that subtraction I mean to addition, it becomes plus a negative x cubed. We're changing that to addition. Instead of subtracting y cubed, we're adding a negative y cubed. Now, could we put this one in standard form? According to what we just talked about during correcting, could we actually put this one in standard form?
No.
No, we don't even call it standard form. We would call it, what they say is algebraic etiquette, kind of. Alphabetize it. So which terms are like terms, and we would probably start with, if we want to just have it in nice algebra etiquette form. Which terms are like terms that we could start with when we're rearranging? Jen? The x's, okay? So 2x cubed plus negative x cubed, they're going to take the front. And our 7y cubed and our negative y cubed are going to take the back. So we just rearrange, putting the things together that can be added together, okay? So 2x cubed plus negative x cubed. What is that? We got 2 of one and a negative 1 of the other. What is
X cubed.
just x cubed? 2 plus, there's like a 1 in here, isn't there? Okay, so 2 plus negative 1 is 1, so that would be x cubed, 1x cubed, also known as x cubed, plus, we bring these guys together, so we have 7, so we'd have 6y to the 3rd. Okay, does that need cleaning up? Does that need cleaning up? No? Is it in alphabetical order? Do we call this standard form? No, there's more than one variable involved, so we don't really talk about standard form when there's more than one variable involved. We just talk about the form that they might like us to write it in. Okay? Okay, so any questions on that one?
Cubic.
Okay, this is a degree what? What? It's a degree what? What's the degree of 3? Answer 3.
Oh, you know, that one.
Degree
Cube one.
3, because each monomial has the same degree, right? So it's a degree 3 and it has 2 terms. So in reality, we would probably call this a cubic binomial. Okay. Tell me something about number 4.
There's a lot of exponents.
There's a lot of exponents. Okay.
Yeah.
Okay.
They're like almost all the same.
Yeah, they're all.
They're almost all the same. What does almost all the same mean? What does that mean? You know what?
They have different leading coefficients.
They have different coefficients, not necessarily leading, we wouldn't necessarily call them. We would say they all have a different coefficient. I'll agree with you on that. Okay, Aaron and Katie, are you gonna make this work here?
Yeah.
Good.
Yes, ma'am.
Okay, John, did you,
Oh, yeah, there is multiplication in that problem.
there's multiplication in that problem. Where?
Oh, you're multiplying m and n like 3 times.
Okay, so you got a bunch of m's being multiplied, a bunch of n's, is that what you're saying?
Yeah.
Okay, so what?
Well, that's what you asked.
Is that gonna matter when we're adding?
Maybe, yeah.
Maybe. What's important for us to be able to add monomial terms?
Oh,
They have to be
wait a
like
minute, you
They
can
have
just
to be
multiply the
like
terms.
Terms, are any of these like terms?
Yes. Yes,
Yes,
ma'am.
they're all like terms.
How do we know they're like terms?
Because I can
All
tell.
the
wait.
m's.
Because you can just tell.
Yeah.
They spoke to you?
Yeah, I have common sense.
Common sense. That's all it takes is common sense. Okay.
Yeah.
So they're like terms because Caden has common sense.
Yeah.
Okay.
Not very much, but yeah.
What if he didn't? Can we trust that?
Well, all the m's.
Why do they have like terms? Because let's try and talk mathematically intelligent. Aaron, why are they like terms?
Because they have like the same base value, so like the
All the m's are cubed and all the n's.
Ends are squared.
Okay, there you go. The same variable parts, that's how we say it.
Sense
They have the same variable parts.
Knowledge.
Every one of them are m cubes, n squareds, aren't they? All 3 terms, all 3 monomials have the same variable part. That's what we look for. Do they have exactly the same variable part? They're all m cubes, n squareds. We have 9 of them, we have 5 of them, and we're taking away 13 of them. So let's add these guys together first. How many do we have there? We have 14 of them. So we have 14 m to the 3rd power
Oh, and that's
n squared. And from that, we can take away 13 m cubes n squares.
I guess I don't use common sense, but I thought it was 2.
Oh, well, sometimes it fails you, huh?
Yeah.
14 take away 13 is?
1.
1.
2 apparently.
Yeah. Do we need that 1 there?
Nope.
No, so we really have the polynomial. Okay,
Well, that's multiplication, so what would we do for standard form?
can we do standard form in this one?
Oh, no, you can't.
Because what?
There's more than one, right?
There's more than one variable involved. Okay, what, this is a 1-term polynomial. What do we call it when it's a 1-term polynomial? A monomial. What's its degree?
Linear? No, cubic.
No,
Fine.
it's a 5th degree.
Oh, yeah, that's.
Yeah, when it's a monomial, you add the exponent. So this is a 5th degree monomial.
That makes
A what?
quintet.
No, this is not a quinting. Oh, I see what you're saying. Oh, I get what you're saying, their degree. There is a special name for degree. Thank you, Aaron. It is a quinting monomial. And Aaron's, overruled the teacher and he's right. Okay.
So it's
Oh.
new teacher now?
Okay.
Is Aaron the new teacher?
So every time in this front, all 4 of these, we were adding monomials, adding or subtracting, or both monomials. Let's go to the back side. When they are not just monomials being added, they are other types of polynomials. Parentheses show the polynomials that are being added. So we have in this very first one here, number 5, we have a polynomial that, tell me something about that polynomial. What kind is it? What is it? What's its name?
Oh, you know that.
Oh,
It's a
4m squared plus 5. What is that?
That is
it's a
a
quadratic
Quadratic
binomial.
binomial. Being added to a what?
A quadratic.
Quadratic trinomial, okay?
Can you repeat?
So we have a quadratic binomial, in parentheses here, we have a quadratic binomial that is gonna be added to a quadratic trinomial.
Oh.
Now, when it's addition, here's the thing. Does not match, those parentheses don't do anything but show the two polynomials. That's their only role in addition, guys.
Yes, ma'am.
Yeah, I'm gonna be buying a book at the end of the year.
Add it to
The
the file.
parentheses only show that they're polynomials. Now, when it's addition, we get to just ditch them, we can just drop them, and we can do the same things we were doing on the front side. So let's, let's do two things in the process. Let's drop the parentheses and change subtraction to add the opposite. So we're going to have 4m squared plus 5 plus m squared plus a negative m plus 6. We're going to rearrange these so that our answer would end up in standard form. So what comes first out of all of these monomials, which like term should be first in standard form?
M squared.
The m squared. So we'll have the 4m squared and the m squared come to the front of the line. What would be next?
Minus
The negative m would be next. Are there any other m's? No. And then the constants would bring up the rear. So we now can combine our like terms and say this group of like terms becomes what?
6m squared. Oh,
5.
5m squared.
5m squared. We have 4 of them plus 1 more. That's 5m squareds. Anything for that negative m to be added to? No. So m5 plus 6? 11.
Oh, yeah.
Is that how we're going to see it in an answer bank?
No.
No. It's going to be how?
You change that plus the negative to this minus m.
So 5m squared minus m plus 1 would be our final
Plus 1.
You mean
Plus
11?
11.
plus 11.
Wrong.
Yeah, okay. So we ended up with what kind of a polynomial answer?
A quadratic.
No?
Quadratic trinomial.
Quadratic trinomial. Now, again, it all depends on how the terms combine, what you're going to end up with. You cannot say every time this is going to be the sum. If I have a quadratic trinomial in my problem, I'm going to have a quadratic trinomial answer. It has to be according to when you combine like terms. Do you still have that term? They may just end up canceling each other out. John?
Shouldn't it be a cubic trinomial?
Why would it be cubic?
Because of the m.
M to the, what power would it have to be if it was cubic?
First.
Zero. That's we did.
No.
But
The
it's
degree of the polynomial is the degree of the largest degree monomial.
Oh.
So 5m squared, a negative m, and an 11. What's the degree of 5m squared? 2. The degree of negative m is 1. The degree of the constant 11 is 0. What's the largest of all of those? 2. So it's a degree 2 polynomial. We don't add all the exponents of all the monomials. So it's a quadratic
We
trinomial.
only do that when it's a monomial.
Only when it's a monomial. That's right. Okay. Let's do this next one where we're going to, first of all, we're going to ditch the parentheses because it's addition in between, so we can do that. We don't have to worry about them. And we're going to change any subtraction along the way to add the opposite. Get in this habit today because tomorrow when we start subtracting polynomials that are not monomials, that's where students start messing up. We're subtracting a whole polynomial, and within that polynomial, there's sometimes subtraction. So the first thing we're going to do here is change subtraction to add the opposite, then we'll start rearranging. If we want this one to end up in standard form, what like term should start it out?
5a cubed.
The 5a cubed and the
7a.
7a cubed. Sometimes when you have a lot of terms like this, the thing to do is this. Go like this and say, I've used those up, so make sure you don't put them in there again. Here, use that. we have any other A cubes?
No,
No, okay, so what are we gonna do, what should come next?
the A squared.
The A squareds. So I got a plus 3A squared, I've used that up, and then we got a 12 plus 12A squared. Any other A squareds? No, so what would be next?
The A's.
The A's, which are negative 6A and negative 10A. Okay, so I used that one. Is there any monomial terms left that we did not account for? Looks like we've got them all. Okay, so now we'll combine like terms. We have how many A cubes? 12. And they stay A cubes. We're adding, not multiplying. We have how many A squares?
15.
15A squares. We have how many A's?
Negative 16.
Negative 6 plus negative 10, negative 16A. How would this clean up? Or is it already? Is this how we would see it in an answer bank?
No,
No, it would look like,
the 16A or minus 16.
okay. Can we talk about this one being in standard form?
Yeah.
Okay, because it only has
A's.
A's. We have it from greatest degree monomial down to least degree monomial. Okay, leading coefficient is
12.
12. What type of polynomial do we have, John?
Cubic trinomial.
We have a cubic, because it's degree 3 polynomial. We have a cubic 3-term, so trinomial. Cubic trinomial is what we end up with. Okay. What do you do number 7? Oh, number 7. I get the polynomial 7xy plus x plus y. Okay. Algebra etiquette, what they would probably really do with this one, chances are, they would have the 7xy and that x trade places. So I don't really know why. I can't even answer that question. X comes before y. So typically they want all the x's at the beginning and all the y's at the end. So because both of these terms have x's in them, the one that's just x alone is first. The one that has an x but it also has a y would be next, and then the one that just has a y. I don't know who decided why it got to be that way, but you know, it's kind of like who decided that the knife and the spoon are on the right side of the plate and the fork's on the left side. I don't know if that's how you do it at your house, but that's how we do. So, you know, some of these things, who decides those things? We don't know. So, okay, anybody have any questions about that one?
No.
Okay. Now, I already know that some of you are in here like, you are making us show so many extra steps that are so unnecessary. Anybody having that feeling right now?
Absolutely.
Absolutely. You're like, what in the world? I mean, you're making this so much work, LeGrand. Why? I don't get it.
I wouldn't consider this work, but yeah.
Yeah, it's like I'm using lead that I don't really need to use. Well,
Lead.
what's going to happen tomorrow is we're going to introduce subtraction. And subtraction, we're saying here we have a polynomial plus another polynomial. And when we're adding, it does not matter. But when we're subtracting, we're not going to be just subtracting one thing. We're going to be subtracting a whole polynomial that may have several monomial terms involved in it. So when we kind of just stay in the habit of showing some extra stuff, it will help us be more successful with those other ones. So here we'll just ditch the parentheses. And I'm going to do this one without changing that one to add the opposite. I want to make sure that you can tell me what I should do then. If I don't change it to add the opposite, when we're doing addition, if you're like, you know what, when you're doing addition, I don't care, it's it's so stupid to do that. What would I do now then to rearrange these terms? John? No? What would I do to rearrange these terms? I want to put it in standard form in the end, so I might as well do that along the way. So what terms would come first here? What would it look like?
The x squared
The x squared. So 14 and 3/10 x squared
plus the 2.6.
plus the 2, where's my squared there? Plus the 2.6 x squared. What would be next?
Plus 5x.
Plus 5x
Minus 4.
Plus negative.
minus 4. Yeah, so we keep that subtraction plus 1. Okay. Now, what can be combined here?
X squared.
X squareds. How many x squareds do we have then?
16.9.
16.9 x squared. Okay. Plus what?
5.
5x.
Not that 5x doesn't have anything to be added to it. Okay. And then what?
Minus 3.
Minus 3, because we have a negative 4 that we're adding 1 to, which is like a negative 3. Is this cleaned up already then?
Yeah.
Yeah? And is it in standard form?
Yeah.
Okay, and again, what kind of, it only has x's in it, so can we classify it?
Yep.
Quadratic,
See, we're not
trinomial.
as stupid as we look.
So we're gonna stay in the habit of doing that also.
Well,
Yes, John?
Is the reason why we have to do, add the opposite is because of the distributed property?
Partly when we start multiplying and because of the, and also it's kind of like when we're doing subtraction, we are distributing a negative 1, so yes.
Time flies when you're having fun with that.
whoa, wow,